Yeah, so I'm a psychologist by training, and I'm going to talk about architectural cognition, human-centric evidence for design. And very often I'm asked, what does a psychologist find interesting of dealing with architects, with urban planners, with the future of cities? God bless you. And my answer is, well, there's a long tradition in this topic, right? Actually, I love to bring physical props. This is a physical prop. This is a book from 1969 about architectural cognition. Everything is without computers, it seems, and the little illustration here is actually punch cards forming a house, very 1960s. And if you go through this book, you find that all the topics that are currently being discussed at the interface between design, the built environment, the role of humans, psychology, neuroscience in architecture is now a big thing. I don't self-identify as a neuroscientist, but some of my best friends are neuroscientists. There's lots of exciting work happening there, especially with the Academy of Neuroscience for Architecture. But I will not go into too much detail of the results of our studies. What I will try to do is give you a very brief sketch of what we are doing in Singapore as part of the Singapore ETH Center within the Future Cities Laboratory that links these matters of the human condition and the built environment. It goes under different names. One very long description is human-centric evidence-based design. I prefer to call it architectural cognition or architectural psychology. Typically for ETH endeavors, and also true of the endeavor in Singapore, is that this is a highly trans and interdisciplinary effort. So our team consists of architects and urban planners, cognitive geographers or human geographers, psychologists, neuroscientists, and quite a bit of computer science. In the extended frame of the project, we have also design architects, to bring in a bit of practicality and, again, a lot of computing. I am not going to talk about work with Dirk as part of the Singapore ETH Center. We also have a joint project, and Rohit was talking about some of that earlier today. I'm really going to focus on what we do in a module called Architectural Cognition and Practice, and we've been involved under different names for this topic for 10 years now in Singapore and hope to continue in the currently planned next phase as well. What we look at is living conditions in highly built environments, primarily in Singapore, but also in other parts of the world. Typical examples could be a shopping mall. A lot of urban living in Singapore, thanks to the fact that it's always nicely warm and fantastically humid, happens indoors. Could be office spaces, but can also be hospital spaces, which is a type of case study that we especially look at now here in Zurich in a close collaboration with University Hospital in Zurich that is ongoing. The basic logic is as follows. When it comes to the built environment, there are at least three main relations, namely the ones between designers and the buildings. That's fairly trivial. Designers build buildings. The process isn't trivial at all, but the logic is straightforward. Then there is a relation between buildings and people. People live in buildings and they use buildings. And there's not even a really nice word to describe these people, right? So designers can be designers or architects or something. And in buildings, sometimes it's visitors, it's patrons, it's residents, specifying certain uses. And on some level, they are all using and inhabiting these buildings, and there's clear relations between the built environment or the building and its function and the users that is a bit similar, perhaps, and this is my personal historical background, similar to the relation between humans and computers. And there's a billion-dollar industry of human-computer interaction, asking about user experience, usability, how to improve that. There's ISO norms on that, etc. When it comes to the same relation between the built environment and human behavior, we don't rely on ISO norms. We rely on the intuition of stakeholders and the intuition of the architects, mostly in the term of this anticipation. So a designer, being a trained expert, has to anticipate how the built environment will be used, how it will be perceived, how it will be felt by the users, while this built environment is still hypothetical, while it is still in a design stage. And that is a challenge to the expert designers that is not to be underestimated. And there's tons of examples where architecture generates fantastic spaces that make people happy. But there's also tons of examples where architects design spaces that at some points fail to make people happy or support their needs. And this is where then architectural cognition and practice comes in, bringing together cognitive science and design with this idea of understanding the usability side of things and informing the design side of things. So infusing via some, well, indirect road of generating evidence, perhaps, the design process in the long term. That at least is our aspiration. I'm not saying that we always adhere to this. In the project, we follow a three-partite approach. We look at fundamental research, we look at reflective research, and translational research, bringing together what has been in the past fairly disparate traditions. Fundamental research aims to increase the understanding of person-environment interactions and the impact on cognition, decision-making, and experience. This is traditionally in the realm of what's often called environmental psychology, looking at what is the impact of environment on people. So that's the more fundamental research part that is increasingly evolving also into taking account these matters of usability, user experience, etc., that may become more from the HCI domain. Then there's the matter of reflective research, which is about considering how well designers conceptualize their end users. This is a topic that is rooted in a different tradition, a tradition that much more is also inspired by phenomenology and humanities scholarship inside architecture and urban planning that looks at the role of architects, the role of designers in creating new good spaces. This is traditionally investigated within the field of design studies or design science, looking also at how to train architects, what kind of tools they need to become efficient architects, etc. And then, and this is partly because we are working a lot in Singapore, where there's a strong demand for not only doing foundational research, but clearly demonstrating the applicability of what we do in practice scenarios, comes in this matter of translational research. After we have scrutinized, or in parallel to scrutinizing the users and the designers, we have to look at how to translate. So we have to work to equip design teams with knowledge and tools to be able to apply learnings from architectural cognition, the stuff we do, into, ideally, their design practice. Singapore is an environment where the state or the government has a very strong impact on how things are done and regulated, and therefore we work equally when it comes to this translational work with stakeholders in the private sector. So anything ranging from small boutique architecture companies to large-scale architecture firms and engineering firms with thousands of employees, on the one hand. But we also work very closely with Singapore government agencies, for example, the Urban Redevelopment Authority, the Housing Development Board, which looks at residentials, and the various transport authorities in terms of how to integrate such science-based efforts into the larger scale of improving livability, if you will, in Singapore. Just to give you a few examples, in the fundamental research stream, we look at how do people use and live in buildings? What do we know about the human-environment relationship? How do we build spaces that inspect users? And actually, I could put up my prop again to say, this is an old question, but we're using lots of new methods, largely computer-driven, partly AI-informed, to improve our data collection and data interpretation in these scales. We started out doing a lot of research on wayfinding. How do people find their way in complex built environments, inside and outside? And I'm not talking about bicycles, I'm not talking about cars, so this will be much less contested. I'm only talking about people going by foot, and I'm sure we all agree that that can be quite healthy, unless you get run over by other modes of traffic. We do a lot of work on human perception, for which we use eye tracking. I'll show you an example in a minute. We translate some of our findings into agent-based models, partly due to the fact that, of course, we're really interested in is hypothetical architecture, counterfactual reasoning, things that don't exist yet, where we cannot just go out into the real world and test them, where we need to find ways of either doing virtual reality experiments or agent-based simulation to get an approximation that is useful, and it is also useful at the time scale at which architects work. They work at a time scale where there's never enough time to talk to scientists and there's always demand to be very quick, right? How can we infuse something that you can maybe have an impact on in an afternoon or within a week, and not over the weeks and months that we as psychologists tend to take to run a proper experiment with statistical significance that we can publish in a really good journal, right? And maybe staying at this pragmatic level, maybe for a minute, these are the design steps as defined by the Royal Institute of British Architects. So you start out very strategic and conceptual, and then you trickle down to actually implementing your building. And this refers to what I already alluded to. A lot of the research that happens in architectural psychology, architectural cognition, etc., comes after the fact. It has this infamous name of post-occupancy evaluation. You do the science when it's basically too late for this building, hoping to learn something for the next building. And that is very informative, very realistic, and is an important part of the kind of work that we do, especially in a multifaceted environment like Singapore, where there's so many really diverse, large-scale, complex building sites where you can spend a decade to try to really unravel how humans engage there. There is a certain tradition of doing full-scale mock-ups of parts of environments, but that's mostly for accessibility testing, seeing if people with handicaps, for example, can use these spaces, etc. Then, if you want to move into earlier stages of design, you have to basically enable counterfactual reasoning of the designers, and one way to do that is behavior experiments in virtual reality, which basically means you take a game engine, put your architectural assets into it, get either some really fancy goggles with built-in eye tracking or a room-filling cave or some other nice environment in which you can realistically project those spaces and measure people's responses. There's also a strong tradition in architecture and urban planning to do spatial analysis to investigate ahead of time potential impact of spatial configuration on human behavior and emotional propensities. The most prominent of them is space syntax. Just now there's a book posthumously coming out about Bill Hillier's early writings. His very first publication, mind you, is in this book, 1969. So that there's a whole range of analytic approaches, and all of these together ideally feed into agent-based simulations that would even be useful when some of the detailing of the layout isn't even available, when you still are at early stages. And this, just to illustrate this a little bit more, we very often go into the real environment and do studies on wayfinding or occupancy, or where in a piazza people like to sit because this is a nicer view than this other view, right? Or we do these virtual reality studies that I just sketched. We do spatial analysis with space syntax or these agent-based models. And this up there is an example where we went in with Frankfurt Airport, who are using the standard model of CAST from Aachen, right, which always assumes that all the agents, all the people in the airport know where they are exactly, know exactly where they have to be, and how is the fastest way from A to B. I don't know what your experience in an airport is, especially in Frankfurt Airport, right? Mine is that these parameters don't always hold. And with some modeling, we were able to show that if you make it cognitively a bit more realistic, people might get lost. People might have to stop and scratch their head. And looking back at the crowd level simulations earlier on, if you have enough people stopping and scratching their head, that clearly changes the dynamics in the crowd and also changes the dynamics in queuing and in the chance of you reaching your flight on time. Let me illustrate a bit further. So this is how a typical underground environment in Singapore looks like. We might equip people with these eye-tracking glasses that look into the environment and at the same time make video recordings of people's visual behavior, and that allow us, and I hope the sound is really turned off now, yeah, to make these videos of people, for example, walking through Frankfurt Airport. This is very early in the morning before the big queues start. An hour later, it looks very different. And the orange donut illustrates where our participant was looking at. And most of that research was done 10 years ago, and we had needed lots of human minions to hand code all the behaviors that were happening. And nowadays, thanks to AI-enabled technologies, a lot of that analysis can be automated. You can even now have automatic scene reconstruction from non-stereoscopic videos that help you actually map this directly into the architectural plans or into the architectural models, which give you a lot more information than what we had at the time. I'll also, in passing, mention the Seattle Central Library, because very often a criticism of architectural psychology or architectural cognition work is you only take those obviously terrible places, like an airport or a train station or something else that is overly complicated. But we also edited this nice book about this Seattle Public Library by Rem Koolhaas in Seattle. And it's a really interesting sculptural building. It won lots of prizes. It's a fantastic library. It's reinventing the library for the digital age, but people get lost like crazy. We did an experiment that I really enjoyed with only 12 participants, and that's the one we didn't publish, where we invited 12 of our friends, all of whom spatial cognition researchers, so people who really care, and made them walk through the library and find certain destinations, and people did get lost, right? Then we went back and did a proper study with a proper sample, and not with scientists, but with people off the street. And again, we can demonstrate that certain structural features of this building confuse people, and that they not only are triggered by the geometry, but also by the place, by the meaning, by the expectations that they associate with the space, where they think maybe a lecture hall in the library should be, or anything else. I'll not go into more detail, but I really like this quote here. I found the ever-narrowing floating escalators to be frightening and left the building as soon as I could figure out how to get out, hoping I wouldn't have an anxiety attack first. Right? So if I ever need a quote to demonstrate that buildings and architecture can affect human emotion, that's a very good version of it. We did all sorts of again, at the time, not AI-enabled tracing of human behaviors in the building, and could, for example, show that this task where if you know where the destination is, where this DVD that you're looking for is located, and trust me, according to the librarian, it is at the logically correct space in the building. Hardly anybody goes that way. They just follow their intuition of the building. They follow the geometry. They follow the light, what is inviting. And that distracts them. And then hardly anybody walks this short path, but you see them all over the place. Right? I know I only have maybe 2 minutes left, and I'll completely shift gear just to show you a very different type of data that we also are sometimes looking at, and that at the surface has nothing to do with architecture. It's called Sea Hero Quest. It is a research effort that was initiated by Hugo Spears and other colleagues from University College London. It's a video game sponsored by Deutsche Telekom a few years ago for handheld devices. And we were able to convince, thanks to a big marketing budget from Deutsche Telekom, to have 5 million human users volunteer their data. They played this video game in which you steer a little boat. Very whimsically, the background story is that your grandfather is suffering from dementia and you're traveling through these island archipelagos to collect some memories for him to share, because it is a game that ultimately is to inform Alzheimer's research. And the tasks in this game are all designed to replicate typical human spatial cognition behaviors. Finding your way without a map, finding your way with a map in a more or less complex environment. And we teamed up, I'm not going into details, but we teamed up with architects and urban planners, specifically with Ruth Conrad Dalton, our long-term collaborator from Northumbria University, and she designed the archipelago in such a way that in its structure, it replicated the way that European cities are built with central and less central places, rings and connectors. And this allows us in this video game to identify behaviors that are corresponding to how people behave in real environments. And without going into details, I know for somebody like Dirk, this is trivial, getting on the cover of Nature, right? But for us psychologists, that is an achievement. Looking into how people who grew up in cities with very regular street networks and people who grew up in traditional, more organically grown cities, how they differ in their long-term ability to process different kinds of spaces, and how you grew up determines how good you are at playing different kinds of levels in this video game based on 5 million users. I have 1 minute left, and I will close by bringing things home to the university hospital here in Zurich, where I got confused. That direction is the emergency department of the university hospital, where we've done now some studies and continue to do studies where we put RFID tags on staff members, all volunteered, all ethically cleared with the ethics committee, to record their movement trajectories and find out whether the way that the place is organized is conducive or hindering the staff interactions that often have to be done under stress in a hectic environment in an emergency department. And we not only do agent-based simulations and all the AI-enabled stuff, but we also do real-world simulation. The Swiss government has started funding the Swiss Center for Design and Health, which in a very nice refurbished industrial space has this high-resolution projection space into which our emergency department neatly fits, and in which we then run simulations of hypothetical behaviors, potential changes, and connect agent-based modeling with cardboard walls. Thank you.